All right. So, very good afternoon to all of you. Good afternoon. So, we start now. Sorry. Tell me first. Are the voice and screen clear? All of it? Yes, no. Are the voice and screen clear? All okay? Yes. Good. Sure. So, now we are studying, guys, electric potential. Okay, let me write that once again. Okay, let me write that once again. Just a second. Fine. So, yesterday we wrote electric field at a given point. Electric field is produced because of a charge system. What is a charge system? Charge system can be a point charge, a collection of charges, or maybe a charge object. In a space around that charge object, there exists something called as electric field. Okay, and because of that electric field, if any other charge exists or placed in that electric field, the other charge will experience force. An electric field can be found by measuring the force acting on the unit positive charge. So it is Fr upon Q, or force acting on given charge upon given charge. Fine, sir. Fine. Next, just like this definition, we can have the definition of potential. Just like electric field intensity at given point, we have a definition of electric potential at given point. Okay. It is what? It is electrical potential energy of given charge placed at a given point divided by given charge. Okay. Just like force acting on the given charge divided by given charge. Just like that. Electrical potential energy of the given charge divided by given charge. Okay. So it is potential energy or the interaction energy. Electric interaction energy means potential energy per unit charge if placed at that point. If placed at given point, if we place a given point charge Q at given point, then at that point find out the potential energy of the given charge divided by given charge, we will get the answer. Fine. All right. These things we know. So the definition yesterday that we wrote is electric potential or at a given point in the electric field, electric potential is defined as interaction energy of unit positive charge. Interaction energy of unit positive charge means potential is equal to energy if this Q is equal to +1. If Q is not equal to +1, in that case, you have to find potential by this formula. U upon Q. But if you put Q equal to +1, then this energy numerically becomes equal to potential. Their units are different, but their numbers will become equal if this Q is equal to 1. Therefore, generally in the definitions people use unit positive charge. Okay, when divided by charge, they say unit positive charge. Why? Because it becomes very easy to define. Electric potential is electric potential energy. Electric potential is electric potential energy of whom? Of unit positive charge. Means divided by charge. Unit of U and unit of V are different, but they can be numerically equal if charge is 1 coulomb. But if the charge is not 1 coulomb, in that case, you have to divide it by Q. Okay, sir. Got it. Okay. Fine. This is a vector quantity. This is a scalar quantity. Okay. All right. Second definition. Electric potential at a point or at a given point in the electric field is one more definition, is potential energy per unit charge. You could have written, instead of this interaction energy of unit positive charge, you could have said potential energy of unit positive charge. Potential energy of unit positive charge. Again, U upon Q. Potential energy of unit positive charge placed at that point. Or simply if placed at that point. Placed at that point. Okay, sir. Fine. In the electric field, we have to place a point charge Q. Let's say this is the electric field. These are the electric field lines. And here at this point, we want to find out potential. What we have to do? We have to bring unit positive charge from infinity to given point, and then we have to find the potential energy of that unit positive charge. By definition, you have to bring plus 1 coulomb. But generally, people do not bring plus 1 coulomb, and therefore they have to divide. Actually, plus 1 coulomb bring karala. Sorry, okay. The plus 1 coulomb is to be brought. Okay. You are asked to bring plus 1 coulomb. So generally, people do not bring plus 1 coulomb. They just bring 2 coulomb. 2 एवढा charge आता. ठीक आहे, मग त्यांना divide by 2 करावं. So at given point, if you want to find out the potential, then first of all bring that charge Q from infinity to given point. Find out the work done or the potential energy. Divide by the charge Q. Potential energy of given charge divided by given charge. Okay, and this is the electric. This is your electric field. In that electric field, if you do this calculation, you will get potential at given point. Potential at given point. Okay, fine. It is very similar to the concept of gravitational potential. It is very similar concept to the concept of gravitational potential. Okay, fine. Now one more definition. We replace this interaction energy word by potential energy. By potential energy. Now we can replace the potential energy word like this. One more definition. See how simple it is. Let me write. Electric potential at a given point in the electric field is electric potential at a given point in the electric field is. Now this potential energy word, see how it is, or this entire statement, see how it is going to be replaced. Is work done to bring unit positive charge. Okay, unit positive charge from infinity to given point. Now you people tell me, work done to bring unit positive charge from infinity to given point means what? Potential energy of unit charge. Potential energy of unit charge means what? Interaction energy of unit charge. That means what? That means what? That means potential. Is that clear? Reply in the chat. Yes. This definition, is that clear? Work done to bring unit charge from infinity to given point means what? Sir, potential energy of unit charge. Potential energy of unit charge means what? Potential energy of unit charge means what? Interaction energy of unit charge. Interaction energy of unit charge means what? Sir, potential. Okay. One phase is still remaining. This charge is to be brought. Work done can be equal to potential energy. Let me give you that extra point once again. Work done by the external force will be equal to changing kinetic energy plus changing potential energy. This work done can be equal to changing potential energy only if this kinetic energy change is 0. And here we have written work done as potential energy. Here we are writing this work done as potential energy, means changing kinetic energy is 0, means acceleration should not be there. So this charge is to be brought. without acceleration. So electric, I made a mistake. Electric potential at a given point in the electric field is the work done to bring unique positive charge from infinity to given point, but it is to be brought without acceleration. Without acceleration. So that this work done will completely get converted into potential energy and will not be utilized for changing kinetic energy. Okay, sir. Fine, no problem. So this work is also important without acceleration, because here work done is equated with what? Equated with potential energy. Potential energy means interaction energy. That completes the definition. So now write V is equal to U upon Q. Okay, sir. Now write unit of electrical potential is equal to unit of potential energy upon unit of charge. Yes, sir. Unit of potential energy is Joule. Unit of charge is Coulomb. Joule, name of scientist, to give the respect. Coulomb, name of scientist. Why do we do this? To give the respect to the scientist. Okay. Let us give respect to one more scientist. Joule per Coulomb. People call this Joule per Coulomb as volt. This V is potential. This V is volt. This V is unit. This V is physical quantity. 1 volt is equal to 1 joule upon 1 coulomb. 1 volt. Now the name of scientist. Complete name starts with small letter. Symbol starts with capital letter. Volt. Volt is the name of scientist. 1 volt is equal to 1 joule divided by 1 coulomb, or simply 1 joule per coulomb. Replying in the chat box, clear and written. Concepts of potential over. Good. Your task. Tell me the dimensions, or tell me the fundamental unit. This is SI unit, that I know, but joule is not the fundamental unit. Joule you have to replace. Coulomb is also not from the 7 fundamental units. I want hold in terms of fundamental units. Do it. That will revise unit dimension automatically. Whenever you learn a new physical quantity, try to find out its unit in terms of fundamental unit. Volt is a derived unit. Joule is a derived unit. Coulomb is a derived unit. Okay, I just given the answer. Okay. Let's see. Coulomb is not a fundamental unit. Okay. Coulomb is also the derived unit. You have to replace the Coulomb. You have to replace the Joule. Let me check. Take 30-40 seconds. Don't hurry. Volt. This V is what? Voltage. Sorry. This V is what? Potential. You may call it as voltage also. This V is a physical quantity, and this V is a unit. Okay. Okay. You're writing the answers. Let's see. Good. Raised to वगैरह टाइप कर दो समय का बढ़ा दो. Let's say suppose kg raised to 3 लाइस है. You can write it like this. Meter raised to 2 लाइस है. You can write it like this. Second raised to -3 lakhs. You can write it like this. No problem. Okay. Don't take efforts. Try to minimize the efforts. Do smart work. Chalo. 1 volt is equal to, or volt is equal to joule per coulomb. Okay, sir. Volt is equal to joule per coulomb. All right. Joule is Newton meter. Do you remember this? Do you remember this? Power is rate of doing work. Power is measured in watt. Rate of doing work, work done upon time, joule per second. So watt is joule per second. Joule is Newton meter because work done is force into displacement. Power is measured in watt. Power is work done upon time. So watt is equal to joule upon second. Joule is Newton meter. Work is force into displacement. So joule is Newton meter. Newton is kg meter per second square. F is equal to ma. Force is equal to mass into acceleration. Mass kg. Acceleration meter per second square. So Newton is kg meter per second square. What is this? Watt. Power wala unit. Similarly, watt is joule per second. Volt is joule per coulomb. Okay, sir. Okay. Current is equal to rate of flow of charge. Taking units on both the sides. Unit of current is equal to unit of charge divided by unit of time. Unit of current is ampere, which is a fundamental unit. Ampere is a fundamental unit. Coulomb is not a fundamental unit. Unit of charge is coulomb. Unit of time is second. Coulomb is equal to ampere into second. What is the replacement for coulomb? Replacement for coulomb is ampere into second. Okay. Ampere is fundamental. Second is fundamental. Joule replacement Newton meter. Coulomb replacement ampere second. This is fundamental. This is fundamental. This is fundamental. We have to replace Newton. Newton is what? Kg meter per second square. Newton is what? Kg meter per second square. This meter as it is divided by ampere as it is. Second as it is. Kg raised to 1. Kg raised to 1. Meter 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 square. Second square second. Second cube. Second cube in the denominator. Second cube in the denominator. In the numerator, second raised to -3. Ampere in the denominator. In the numerator, ampere raised to -1. So this is the volt. This is volt. 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 Unit of potential. Unit of potential is equal to unit of capital V. This V is potential. Unit of potential is volt. And this volt is again V. This volt is again V. And that volt is equal to kg raised to 1, meter raised to 2, second raised to -3, and ampere raised to -2. Dimensions of potential. Dimensions of potential. Kg means mass raised to 1, meter means length raised to 2, second means time raised to -3, ampere. Generally it is written as R or it is kept as A also. Ampere, either current I or ampere only A also okay. So sometimes people write it as ampere current I, or sometimes they write it as A as it is. No problem. Reply in the chat box, clear and written. Done. Now we can find out the unit also. Good. Bio lecture कर दिया बड़ा मैंने. Bio lecture किती वाजता? 2:15. Bio lecture. 2:15. Tell me. Yes. Right. So we will aim before 1:40. Okay. We will aim before 1:40 so that you can get 25 minutes late. So at least 20 minutes late. We'll end it before 2. Okay. Just don't worry. We'll get 15 to 20 minutes. Just don't worry. Next. Write down properties of electric potential. Properties of potential. Electric potential properties we have to write down. Just like properties of electric field. Now we are writing the properties of electric potential. Its unit, its dimensions we wrote down. Now other properties of electric potential. Now we know its unit is volt. All right. Next, properties. Potential is a scalar quantity. Its value may be positive, negative, zero. Right now, properties. Properties of electric potential. Let me write the short forms. Electric potential. Sir, तुम्ही short form का लिहिता? पेनातली शाई वाचवतो तुम्हाला. पेनातली शाई थोडीशी वाचवतो. तुम्ही पण तुमच्या पेनातली थोडीशी शाई वाचवा. ओके. सर का वापरायची शाई? का वाचवायची शाई? लॉकडाऊन चालू आहे. शाई मिळत नाही विकत. म्हणून शाई वाचवायची. हा? तसं नाहीये बाळांनो. तसं नाहीये. लिहिण्यात आपला वेळ वाया जातो म्हणून मी त्याला शॉर्ट फॉर्म मध्ये लिहितो. सर वेळ का वाचवायचा? Because time flows only in one direction. याला बॅकवर्ड करायची मशीन अजून तयार केलेली नाहीये आपण. ओके, ही मशीन तयार झाली मी सगळे शॉर्ट फॉर्म बंद करणार आहे. ओके, ठीक आहे सर, चालेल. नेक्स्ट, SI unit of potential. First is electric potential. Electric potential is scalar. It can be, just keep on writing, it can be positive, just like work done is a scalar quantity. It can be positive, negative, zero. It can be positive, negative, or zero, no problem. SI unit, SI unit, SI unit is volt, which is equal to capital V, which is equal to joule per coulomb, which is equal to joule per coulomb. Okay, sir. It is W upon Q. Sorry, it is U upon Q, potential energy upon Q, and that potential energy is ultimately going to be work done. So even W upon Q is okay. U upon Q or W upon Q, both are fine, perfectly fine. Dimensional formula. Dimensions of potential is equal to, we just found that out, right? H raised to 1, length raised to 2, time raised to -3, current raised to -1. Okay, it was the formula. We just derived it. Just write it down as a property. Number 3. Number 3. Electric potential at a point is also equal to the negative of the work done by the electric field in taking the point charge from the reference point, that is from infinity to the given point. Okay. Okay. What they have written is this: electric potential at given point is also equal to negative of work done by the electric field. Work done by the electric field means internal force. Okay. In taking a unit positive charge or the point charge from reference point to reference point. Reference point is infinity to given point. Okay, reference point. Have I made a mistake? M raised to 1. Okay. So kg raised to 1 nahi, m raised to 1. Okay, fine. Sorry, just correct. All right. Electric potential is also equal to, okay, negative of, okay, work done by the electric field, okay, in bringing a unit positive charge from the reference point. Reference point means infinity to the given. So absolutely no problem. Okay, let's verify whether this is right or wrong. What we know is this. What we know is this. This is what we know. Okay, sir. Now W external. Changing kinetic energy, of course, without acceleration, this is to be done. Yes, sir. Now, call this as equation number 1. Call this as equation number 1. Now, what we know is this. At given point, divided by Q. This is what we know. Call this as second equation. Fine. Now, let us replace this U. Let us replace this U. And for that, let us use this equation once again. Now the external forces will do the work against the internal forces. Okay, and of course we are not changing the kinetic energy. So minus of W internal is equal to, or what you can do is this also. Instead of replacing this, here you can observe that. Here you can observe that this entire work done is going to be changing potential energy, and that is attributed to the internal forces existing in the system. Okay, this will be done because of external forces, this will be done because of internal forces, and we know that right now external work is being done only against the internal forces. Those two forces must be equal and opposite. Therefore, what you can write, it means that this value is equal to delta U, because this is right now external forces are doing work only against internal forces. They are not using their energy for increasing the kinetic energy. Means right now entire external work is being spent against the internal forces. So those forces are equal and opposite, equal opposite forces and same displacement. Work done must be opposite in sign. फोर्सेस इक्वल अपोजिट आहे, एक राईटवर्ड फोर्स आहे, एक लेफ्टवर्ड फोर्स आहे. दोघांची डिस्प्लेसमेंट राईटवर्डच आहे, पण एक फोर्स लेफ्टवर्ड आहे, एक फोर्स राईटवर्ड आहे. सो वर्क डन्स विल बी अपोजिट टू ईच अदर. ओके, डब्ल्यू एक्सटर्नल ची व्हॅल्यू डेल्टा यू पण आहे. डब्ल्यू एक्सटर्नल ची व्हॅल्यू फॉर दिस केस ऑफ द क्वेश्चन इट इज मायनस ऑफ डब्ल्यू इंटरनल पण आहे. सो दिस डेल्टा यू कैन बी रिप्लेस्ड बाय मायनस डब्ल्यू इंटरनल. ओके, ट्राय टू अंडरस्टैंड. Not that difficult. Okay. What is this? What is this? Delta U, final minus initial. Okay, this is final minus initial. What is final? Final is U. What is initial? Initial is infinity. Interaction energy of the system or given charge when the charge is at infinity is what? Zero. Okay, sir. All this as equation number 3. Now you can replace this U by minus W internal. Okay, U can be replaced by minus W internal upon this Q as it is. Therefore, proved. What done by the internal is, of course, who are the internal forces? Electric field forces. Replying in the chat box, clear and written. Just get convinced with the logic. Okay, and don't worry, there are conventions for the sign plus minus. There are already conventions, so I guarantee that you are not going to do any mistake in the sign. Just write this down. While solving the questions, we will deal with the sign as well. Just don't worry. What you can remember is this. What you can remember is this. This is always true. This is always true. This is not always true because work done can sometimes be spent in this also, kinetic energy also. But if it is not being spent, you can always replace delta U by minus W inter. No problem. Okay. Next property number 4. Write down. These are the conventions, and ultimately all the equations are going to follow the conventions. Just don't worry. Even if you remember the conventions, that is enough, because automatically you have to write such equations which follow the conventions. You will observe while solving the examples. Next property. Electric potential due to the positive charge is always positive. Electric potential due to positive charge is positive. is always positive. Is always positive. Just like electric field is always away from the positive charge, and electric field is always towards the negative charge. Just like that. Electric potential because of a positively charged system is positive, and electric potential because of a negatively charged system is negative. Electric potential due to the positive charge is always positive, and electric potential due to negative charge is always negative. Okay, sir. Is always negative. Potential due to positive charge is positive. Potential due to negative charge is negative. Okay, sir. Potential decreases in the direction of electric field. Next property. Write down. Rather than saying this as property, we can take this as convention source. Okay. Electric potential decreases. Okay. Decreases in the direction of electric field. In the direction of electric field. Okay. Fine. Let's say at this point A and at this point B, electric field is directed like this. Direction of electric field is like this, rightward. Direction of electric field is rightward. Potential at point A is VA. Potential at point B is VB. Now tell me which potential is higher? VA is higher or VB is higher? Which potential is more or higher? Which potential is higher? VA is higher or VB is higher? A or B? A or B? Electric potential decreases in the direction of electric field. Direction of electric field is rightward. So leftward wale higher potential, rightward wale lower potential. So can I make one more statement? All of you are giving the correct answer, so you got it. Can I say direction of electric field? Direction of electric field is from direction of electric field is from higher potential to lower potential. Decreases means what? Higher to lower, na? Higher to lower means decreases. Higher potential to lower potential. Direction of electric field is from higher potential to lower potential. Got it? These are the properties of electric potential. Just like properties of electric field or the properties of electric field lines that we studied. Similar to that, these are the properties or the conventions which are to be remembered in case of electric potential. Okay, sir. Fine. So electric field is always directed from higher potential to lower potential. Or in the direction of electric field, potential goes on decreasing. Yes. Here it is higher, here it is lower, again lower, and so on. Okay. Or you can simply say direction of electric field is always from higher potential to lower potential. Potential due to the positive charge is positive, potential due to the negative charge is negative. Fine. So if you have a charged system like this is our charged system. Let's say it is a positively charged system. Then at any point, all these potentials, let's say here the potential is V1, here the potential is V2, here the potential is V3. These are scalar values, but it can be positive, negative, zero. At all these points, not only on the right hand side, at any point, all these people, V1 to V10, all are positive values. All are positive values. Just like if you have a positively charged system, electric field will be away from the positively charged system. Just like that. If you have a positively charged system, then because of a positive charge, potential will be positive. Potential will be positive. Okay. If you have a negatively charged system, all the potentials in a region around the charge system, if you have a negative charge, in the region around that negatively charged system, all the potentials All those values will be negative. Fine. Electric potential due to the point charge. Next derivation we have at 140. You are going to remind me that it is 140. Okay. Next. Electric potential due to the point charge, just like electric field due to the point charge. It was a vector, but this is scalar. It's okay. Derivation. Right now. Electric potential due to a point charge. Due to a point charge. Due to a point charge. At distance equal to small r. At distance small r from it. At distance small r from it. Okay. So now we have a charge system as a unique positive charge. This is a charge system which is a not unique positive charge. I'm going to say a point charge. Any point. Electric potential we have to find out due to a point charge. So our charge system is a point charge. Because of this point charge, at a distance equal to r, at this point, let's say this is point P. At this point, which is at a distance equal to r, we have to find out electric potential. It has no direction. So do not draw any kind of arrow. Okay. Potential has no direction. It is a scalar value. It can be positive, negative, zero, but it is a scalar value. This potential is equal to question mark. What we have to do? We have to use the definition of electric potential. Okay, what is the definition of electric potential? Interaction energy of the charge divided by the charge if you place that charge at this point. Okay, let us place the charge at this point. Let us place the charge at this point. We place the charge equal to small q at that point. And now we have to measure the interaction energy of this charge with the charged system, with our charge system. That's not a big deal. K, what is the interaction energy or the potential energy of charged system and the given charge? K, Q1, Q2 upon R12. R12 is R. This is the interaction energy of the given charge with the charge system divided by R. I made a mistake. This is the interaction energy divided by charge. Divided by charge. So this Q cancel. So what is the potential? So this is K. This is Q upon R. So this is KQ upon R. Reply in the chat box clear and written derivation over. It's a single linear derivation. One line, next day minus. Electric potential due to the point charge. Getting it? समझा लगले? Are you getting it? दिमाग में जा रहा है? सर दिमाग में जा तो रहा है, लेकिन घूम के बाहर आ रहा है. हाँ? हाँ? अरे समझा लगले नहीं? Are you getting it or not? Okay. Fine. Now let us verify the fact. Let us verify the fact or the property. Let's say our charge system is a positive charge. If this charge is positive, this charge is positive. We know distance is always positive. This K value is always positive. 9 into 10 raised to 9. This K value is always positive. This distance is always positive. If our charge system is positive, this potential answer will automatically come out to be positive. So because of this positive charge, at any distance r from it, all the potential values will be positive. Because of positive charge, you will get positive potential. If our charge is negative, its potential because of it, not its potential. If our charge is negative, potential because of it will be negative. If our charge is positive, potential because of it will be positive. Positive charge मुळे positive potential येतं, negative charge मुळे negative potential येतं. Automatically formula काळजी घेतो. You don't have to worry. You just put if the charge is positive, put it positive. If the charge is negative, put it negative. But just remember the convention. Potential because of positive charge should ultimately come out to positive, and potential because of negative charge should ultimately come out to be negative. And that is satisfied by this formula. Okay, fine. Now let us try to find out potential due to system of charges. Okay, potential due to system of 2-point charges. Let's do it. Potential due to system of 2-point charges. First point charge is here, Q1. I want to call it as capital Q1. If you want to call it as small q1, I don't have issue. Second charge, Q2. This is the given point. This is the given point. I want to find out total potential at this point because of this charge system. Now this is our charge system. Yes. At this point, what is the effective potential? Now, just like finding out effective electric field, you have to find out effective potential. How do we find effective electric field? Electric field due to the first charge, electric field due to the second charge, and then vector addition, not scalar addition. Electric field is a vector. Electric field due to the first charge, electric field due to the second charge, and then vector addition to find out electric field. Potential is a scalar quantity. Find out electric potential due to first charge, find out electric potential due to second charge, just add because it is scalar quantity. No need of vector rules. So sir, potential point is quite simpler because we simply have to add. No vector resolution is required. First vector is like this, find out its x component, y component. Second vector is like this, find out x component, y component. Find out net x component, find out net x component, find out net y component, and then find the resultant. This much task is not required here. Find out potential due to first charge, find out potential due to second charge, get the answer. Let's say this distance is R1. Let's say this distance is R2. Find total potential of the system at this point. Potential due to first charge plus potential due to second charge. Because of the first charge, because of a point charge at distance equal to R, what is the potential? KQ upon R. Because of the charge Q1 at distance equal to R1, what will be the potential? V1, which will be KQ1 upon R1. Plus, because of the charge Q2 at a distance equal to R2, what will be the potential? Sir, V2. What will be that V2? Sir, K into Q2 upon R2. This system is a single point charge. This system is a single point charge. Again, the collection gives a larger system. Because of this charge, KQ upon R1, KQ1 upon R1. Because of this charge, KQ2 upon R2. KQ1 upon R1, KQ2 upon R2. This is going to be a number, positive, negative, zero, but a number. This is going to be number. Just add them, get net potential. Decline in the chat box, clear and written. This point over. CW. Finding it easy. Next and last. Electric potential due to system of 3-point charges. Due to system of 3-point charges. Okay, so here we have Q1. I want Q2 here. I want Q3 here. Okay. What is the potential at this point? Let's say this distance is R1. Let's say this distance is R2. Let's say this distance is R3. potential at this point because of this system is equal to question mark. Not a big deal. Just write it down. Potential because of first charge K Q1 upon R1 plus potential because of second charge K Q2 upon R2 plus potential because of R3 K potential because of third charge Q3 upon R. That's it. In this way, you can extend the concept as per the need. Okay, in this way, you can extend the concept as per the need. Just reply in the chat box clear and written. Good. Hmm. Hmm. Okay, sir. Next. Fine. So now we know how to find out potential due to the point charge. Okay, one question is there. Let me read that question. Sir, we can find the potential of a point. Just give me a second. Sir, we can find potential for a point, but potential energy for system. Exactly. See, let us use the words or phrases properly. Force, force on the charge, force by the charge, but basically that force is in between the two charges. Sir, you wrote V of the system. That means potential because of this system at this point. Potential because of the first charge plus potential because of the second charge plus potential because of the third charge will give me potential because of the system. Now, potential of the system, I am not saying potential of the system, I am saying potential because the system, because of the system. Okay, let us write down all those phrases. Okay, force between the two charges, force because of the first charge, force because of the second charge. Now, let us just discuss potential energy of system of charges. And even if someone says potential energy of a charge, even if someone says potential energy of a charge, you should understand that that charge is certainly that another charge, potential energy of this small charge q. If someone is saying potential energy of this small charge q, then he is certainly saying that that charge is definitely placed in someone else's electric field. This is a charge system, and because of this charge system, some electric field will be produced, and in that electric field, this charge will be placed. So potential energy of this charge, actually they are saying potential energy of this charge in the electric field of this charge. It's actually it is the interaction energy of this system. Interaction energy of this system. Okay, fine. Now here potential will be because of whom? Here, the potential will be because of the given charge system. This charge system produces the electric field. This charge system also produces the potentials. So at different points around this charge system, there will be potentials. And because of this charge system itself, there will be electric. And in that electric field, other charge will be placed, which will be experiencing the force. Okay, which will be experiencing force because of this charge. And when someone says potential energy of this charge, they are actually saying potential energy of this charge. Okay, it is nothing but potential energy of this charge in the electric field of this charge. Potential energy of charge as such can लिहित नसतं, पण त्याला स्टेटमेंट जनरली कंटिन्यू आपण केलं पाहिजे. नाही केलं तरी समोरच्याला समजतं, because all these conventions are properly clear to everyone. Okay, त्यात काहीही confusion. Fine. Now here potential of the system, this is not the correct word. Potential because of the system. But I am writing V of the system. Now we should understand it by our own that this is the potential because of the system. This one, and this one. This one is potential because of Q1 at distance R1. Because of Q1 at distance R1. Because of Q2 at distance because of Q2 at distance R2. Because of Q3 at distance R3. Hope that is clear. Fine. Now let me continue my statement. Sir, it's like potential because of parts of systems. Yes. Potential because of the system is equal to potential because of the first part of the system, potential because of the second part of the system, plus potential because of the third part of the system. This is our system. This is first part, this is second part, this is third part. Why we are making parts as points object? Because we have already found out the formula for point objects. Now let me continue my statement. Just wait for a second without asking further out or making any comment. Just listen first. Let me make my statement. Now we know that potential because of point charge is to be found out with the formula KQ upon R. So we can find out potential due to one charge, due to two charges. We can find out potential due to three charges and so on. So our charge system can be a point object. It can be a collection of point objects. A collection of point objects. That point can be tackled like this logic. 3 point charges, 3 terms will be there. 4 point charges, 4 terms will be there, and so on. But sir, what if our charge system is a charge object? Charge object means infinite number of point objects. Yes, no. If you have a charge object, charge system can be of 3 types: point charge, collection of charges, or point charge, collection of point charges, or the charge object. Now, charge object means infinite number of point objects. In that case, addition or integration. Object starts at some point, object ends at some point. But still, in that object, there are infinite number of points. In that case, what we have to do? We have to do integration. We have to do integration. Actually, addition. First point charge, second point charge, third point charge. But those points are so many that we cannot just keep them on adding. Okay, add करत 500 वर्ष झाली ऍडच होत नाहीये असं नको करा. मग काय करूया? इंटिग्रेशन. Okay. Fine. So right now, potential due to the charged rod. Okay. Potential due to a charged rod. Okay. Let's try to find out potential due to the charged rod. Okay, sir. The rod starts at this point. Rod ends at this point. Point A, point B. Length of the rod is capital L. Length of the rod is capital L. Let us take the point on the axis of the rod. This is the axis of the rod. Fine. Let us take point P here. At point P, we have to find out the electric potential because of this rod. This rod is a charged rod. Total length of the rod is L, and on this total length, the total charge on the rod is capital Q. Total charge on the rod is capital Q. Okay. From this point B, distance of given point from this point B, distance of given point is x. Distance of given point is x. Now x can be any value. At that distance, we have to find out potential because of this charge system. Potential because of this charge system. Okay, let us do that. So we do not know how to find out potential due to a charge system, but we know how to find out potential because of a point charge. Now our system is a linear system. Linear system has a very small point object, a very small point length, dl or dx. Yes, no, reply in the chat box. If you have a straight line, its point will be dr. If you have a area or the plane, its point will be dA or ds. Point area ds, point volume dv, point length dl. Okay, sir. So what we can do, we can take any general point object in this rod. We can take any general point object in this rod. Okay, which is located at a distance equal to small r from the given point. Which is located at a distance equal to small r from the given point. Okay, sir. So this is our very small charge dq. Total charge is capital Q. Total charge is capital Q. This is very small charge dq. Its length is very small. Its very small length is, let me draw it properly. Its very small length is dr. At a distance equal to r, let us take a length equal to dr, and on that length, charge will be equal to dq. Very small charge dq is a point charge. Very small charge dq is a point charge. Because of this point charge dq at distance equal to small r, what is the potential? That potential will be dv. Because of the small point charge, small potential will be there, dv. Yes, and because of all such point charges from this point to this point, because of all such point charges, we have to add the potentials. We have to add the potentials. Agree, disagree, reply in the chat. Understand the logic. Derivation not a big deal. Okay, even bio people do not worry about it. Okay, we have done integration so many times. Just have confidence, but try to understand the logic. First, we will find out a small potential because of a small point charge, and then we will consider all such point charges. This is the point charge. And again, next, this is the point charge. Okay, all such point charges we are going to add. Now, our object is a one-dimensional object, so point charge will be having a point length dl, a very small length dl or dr. Right now we are taking distance as r, so point length will be dr. Okay, so let us find potential because of dq at distance equal to r. Potential because of dq at given point p or at distance r, that will be d, small potential. Kq upon r, sir, formula is kq upon r. K. Q is what, sir? Q is dq. Q is small point charge dq. Point charge का formula है kq upon r. Point charge is what? dq. K into dq upon distance of given point p from the given charge. Distance of given point from the given charge is r. kq upon r. Okay, sir. Now, all such point charges, potentials because of all such point charges are to be added. Yes, no, replying in the chat box. Total potential at point P. P is equal to addition of all such point potential, addition of all such small potentials. dv is what? So k into dq, sir, upon r. This r is variable. This r is variable. It is initially x. It is initially x because when this dq is here, it is initially x, and all such dq ultimately come to a. In that case, r will become x plus l. Initially, it will be x. Finally, it will be l plus x. Yes, sir. Check. Initially, it will be x. Finally, it will be x plus l or l plus x. Okay. So our values are going from x value, here point charge, this point charge to this point charge. So x to x plus l. R goes from x to x plus l. Okay, fine. Is equal to. So k is the constant can be taken out of integration. So somehow you have to get rid of this dq. We have the limits of r. We have the limits of r. R goes from x to x plus l. So we have the limits of r. So we have to replace this dq in terms of dr. We have to replace this dq in terms of dr. Now it is very obvious step. It is very obvious step. How to replace this dq in terms of dr? dq is the charge on the length dr. Q is the charge on the length L. So what we have to do? We have dq charge on the length dr. We have total charge Q on the length L. What we have to do? The rod is uniformly charged. What is the concept? Which concept we are going to use? Charge per unit length concept, charge per unit area concept, charge per unit volume concept. Which concept? Charge per unit length concept. Okay. If the charge is uniformly distributed on the rod, total charge upon total length, all these are equation 1. Now, total charge of the rod divided by total length of the rod must be equal to small charge dq divided by small length dr. This ratio must be constant. Only then the rod will be called as uniformly charged rod. Therefore, this dq is equal to this q is equal to this q upon l multiplied by this dr. So generally people call this charge per unit length as lambda into your length. Our length is dr. The charge on the our length, आपल्या length वरचा charge is equal to charge per unit length into आपली length. Charge on your length is equal to charge per unit length into your length. Charge on the given length is equal to charge per unit length into the given length. आपल्या length वरचा charge is equal to charge per unit length into आपली length. आपली length किती आहे? dr. याच्यावरती. So how to replace dq in terms of dr? How to replace dq in terms of dr? Lambda into dr. What is lambda? Lambda is charge per unit length. Linear charge density. Lambda ला काय म्हणतात? Linear charge density म्हणजे charge per unit length. Aerial charge density किंवा surface charge density म्हणजे charge per unit area. And volume charge density means charge per unit volume. Charge per unit length means linear charge density. Okay guys, linear charge density or charge per unit length. That can be observed here, charge per unit length. Or let us write that word as well, charge per unit length. Charge per unit length. Fine. Okay. Now derivation is almost over now. Let's do that. All right. Now we have k into dq upon r. Let me rub this part. Let the diagram be as it is. This potential because of this charge system is equal to, sir, this k as it is. Integration r goes from x to x plus l or l plus x. This k outside integration, this dq is there. Now the dq can be replaced by charge per unit length into length. All this as equation. We are putting equation 2 in equation 1. Charge per unit length into your length divided by this r as it is. Divided by this r as it is. So this lambda is a constant value, charge per unit length out of integration. So 1 k into lambda into integration. R goes from x to x plus l dr upon r. Dr upon r. Okay, what is integration of dx upon x? Just like that, dr upon r, not a big deal. On the next step, we have the answer. I think question is basically over here. The supply question. Reply in the chat box up to this clear and written. Up to this clear and written. Everyone understand it? Make sure that it is clear to you. Make sure that you understand the logic. See how the element is chosen. छोटा सा element. लेंथ साठी एलिमेंट काय असणार छोटासा dr or dl. Object is linear, its element will be a small length. And point charge formula already येतोय. You already know potential due to the point charge. All such point charges and their potentials are to be integrated. Means added. Okay. It's a scalar quantity. It can be easily added. Fine. Integration of dx upon x. Log x. Log x की derivative 1 upon x. 1 upon x the integration log x. Okay. Derivative of log x is 1 upon x. Integration of 1 upon x will be log x. Don't get confused. Write down here. E by dx of log x or ln x log to the base e. Derivative of log x is 1 upon x. Therefore, taking integration on both the sides, derivative integration will get cancelled on the left hand side. Taking integration on left hand side, derivative integration cancel. Taking integration on right hand side. So integration of 1 upon x dx is log x. Take integration on both these sides. Fine. So integration of 1 upon x dx is log x. So integration of 1 upon r dr is log r. So k as it is, lambda as it is. Log r means actually ln r, log to the base e. Logs in the formula are generally log to the base e. R goes from x to l plus x. This distance was x, and finally that will become x plus l. X to l plus x. Upper limit minus lower limit. Put a bracket. Log of upper limit minus log lower limit. Log m minus log n. Log m minus log n is log m upon n. Log m upon n. That's it. Derivation over. Any mistake? Yes. No, no mistake. This is lambda. No problem. You can replace this lambda by q upon l. Log is a unitless value. Kq upon l will give the unit of volt. Kq upon l. Overall charge upon overall length. Ln l plus x upon x. Replying in the chat box. Is this derivation clear to all of you? Clear and written. It's 140 now. Clear? Up to this, everyone. Now we know how to find out potential due to a point charge, due to system of point charges, and due to the object charge object. Write it down. Write it down, understand it, and then reply in the chat box. Done? Very good. Let me give you a very simple task. This can be done within a minute. Okay, this can be done within a minute. Potential, of course, electric potential at the center of charged ring. This ring has a charge equal to capital Q. At the center, what is the potential radius of the ring is R. Try to do it. You may take this radius as capital R if you want. No problem. Total charge on the ring is capital Q. Potential is a scalar quantity. Electric field is a vector quantity. Electric field at the center of the ring will be 0 because symmetrical system. About this point charge, symmetry exists. So electric field as a vector it will be 0. Potential, it's a scalar value. Potential due to positive charge is positive. Potential due to negative charge is negative. Let us take very small point element of length equal to dl, of charge equal to dq. Because of this dq, what will be the potential at the center? dv, which will be equal to kq upon r. K is k, charge q is dq, r is capital R, radius of the circle, kq upon r. Because of this point charge dq, potential at the center is kq upon r, point charge is dq. It's a scalar value, it's not a vector value. Total potential at the center. Total potential at the center of the circle. V is equal to integration dv. Integration dv is integration k into dq upon r. K is a constant, r is also the constant. Radius of the circle for all such dq, 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 all such dq, this dq, this dq, this dq, r is going to be constant. Integration dq over the circumference of the circle. All such small charges are to be added. That will give you total charge on the circumference. Now this r is the radius of the circle. Replying in the chat box, clear and written. This should become your daily task. जो लोग एग्जाम में करेंगे वो हम रोज करेंगे. आता हिंदी मध्ये सांगितलं, मराठी सांगू का? लोग जे एग्जाम मध्ये करतील ते आपण रोज करायचं. इंटिग्रेशन एग्जाम साठी ठेवू नका वाटत, आता करूया. मॅथ्स मध्ये व्हायचं ना बाळांनो तुमचं इंटिग्रेशन. अजून इंटिग्रेशन शिकवायचं ना तुम्हाला? चालू झालं इंटिग्रेशन? चालू झालं इंटिग्रेशन? नेक्स्ट चॅप्टर आहे इंटिग्रेशन. बघा मॅथ्स वाल्यांचं अजून इंटिग्रेशन चालू व्हायचं आहे, पण त्यांना इंटिग्रेशन करता येते. म्हणजे अजूनही मॅथ्स वाल्यांना इंटिग्रेशन झालं नाहीये. म्हणजे काय, आपल्याला जेवढं मॅथमॅटिक्स लागते ना बाळांनो, माझ्या मुलांसाठी पर्टिक्युलरली सांगतोय, जरा पण घाबरू नका. तेवढं मॅथमॅटिक्स जेवढं त्यांना अजून माहित नाहीये ते मॅथमॅटिक्स ते करतायत, तुम्ही करू शकताय. येस नो जरा रिप्लाय करा मला. घाबरू नका या इंटिग्रेशनला. काय इंटिग्रेशन म्हणजे ऍडिशन आहे. फक्त काय ती इन्फानाइट टाइम साठी ऍडिशन करत बसायची असते. मग त्यासाठी लोकांनी रूल्स बनवून ठेवलेले. एवढंच आहे. नॉट अ बिग डील. फॉर्म्युले थोडे लक्षात ठेवावे लागतील. लॉग एक्स ची डेरिव्हेटिव्ह 1/x. 1/x चे इंटिग्रेशन लॉग एक्स. Derivative of log x is 1/x. Integration of 1/x is log x. That we have to remember. And that list of formulae has been already given to you. And that will be revised again and again with the help of the formula. Okay, so just don't worry. And definitely, in the NEET exam, definitely, all the questions are definitely not based on the integration. Either 2 or 3 questions will be based on integration. Okay, so just don't worry about that. There are 45 questions. Okay. Just because 2, 3 or 4 questions are based on the integration, don't call physics as difficult. Okay, fine. So all the things taught in today's lecture clear to all of you guys. Reply me in chat box finally, because we have to take leave now. Okay, fine guys. So in this lecture we are going to stop at this point. Remaining things we are going to learn in the next lecture. Okay, चलो bye. पृथ्वीराज म्हणतोय सर भूक लागली आता, जातो मी जेवायला. चला बाळांनो जेवण करा. चलो बाय बाय.